All right, imagine you're this blue seat. So you're going to be rotating around the Ferris wheel counterclockwise. We can use the sine and the cosine function to describe where you are, what your location is. Okay, here's how we do it. If I want to describe where I am with respect to this center point, and I want to know, am I above it or below it? Am I moving away from it? Or am I moving towards it? I can do that by graphing the height that I'm at any point in time. So for example, as I pull this, my angle is getting bigger. And if you look at this blue dotted line, that height, that would be the y coordinate, is equal to the height that I am on my graph. So as I keep plotting that point over and over and over, now I'm reaching my highest point from the center. Okay, so if this circle had a radius of 1, my highest point would be 1. That would be my amplitude. Now I'm moving back down towards the center point. I'm going to be even with it when I reach when I've rotated 180 degrees or pi radians. Now I'm below the center point, and I'm going to reach the lowest point at 270 or 3 pi over 2, where I'd be at -1, and then I'm going to come back and I'm going to end up even with the center point. Okay, that graph right there, that is the sine graph. So the sine graph is just describing your location if you're above or below. I'm above, I'm at my highest point, I'm even, now I'm below, I'm at my lowest point, and then I'm back even. That's the sine function. So when I'm looking at this graph, this center line right here is the same as the line that is y equals 0. These lines down here, the vertical lines, those are your angles. So as you rotate around, depending on what angle you are, let's say I was at 28 degrees, this height right here is plotted by going to 28 and plotting that same height right there. And we just keep doing that as we go around the circle, and that creates our sine graph. All right, now here's the sine graph. As you'll see, as I start tracing this around, what it's graphing is this height right here, 0.82. Now it's 0.93, then it's 1, then it starts to shrink again, and at 180 it's back down to 0, and then now it's going past 0. It reaches its lowest point, which is -1, and then it comes back up to 0. And that just repeats over and over. That's why we call it a periodic function. So that is our sine graph. All it is describing the height that this point is above that center point. It's either above it on the first half of the circle or below it. All right, now the cosine graph. And now what your cosine graph is, it's graphing the length of the orange segment that you see that's going right and left. So it's describing the length of that orange segment. So it's describing where you are in relation to either right or left. So here, you're as far to the right as you're going to be. You're at the highest point, and highest point because you're at the furthest distance. So even though I'm even with it, I'm measuring, am I right of it or left of it? So right now, if we said this was a length of 1, we would be 1 to the right. Now, as we start to rotate, now we're not as far to the right anymore. And once we reach 90 degrees, Okay, you notice that orange segment disappears because we're not right, we're not left, we're right above it. Now, as I move past that 90 degrees, that orange segment starts to get longer, and now it's -1, which means it's to the left as far as it's going to go. And then that orange segment starts to shrink again. It's 0 because I'm right below the center point. And then it gets longer again until I reach 0 degrees, and I'm 1 to the right again. So the cosine is describing your right and left, which is your x-coordinate, and your sine is describing your up and down, which is your y-coordinate. So this is what one cycle, one period of cosine looks like, and it's measuring how far you are right and left of the center point. All right, so now what's getting graphed is the length of this blue line right here. So right now you see how its length is 1, so my point up here is 1. As the degrees increase, that length gets shorter and shorter. Like there it's 0.5. You see how it's even with 0.5. Then when I get to 90 degrees, there is no length. Then it starts to get longer again, reaches -1, starts to get shorter again, and eventually you're back to one place to the right. That is your cosine function, which is the x-coordinate. All right, last week we learned about amplitude, midline, and period. Today we're going to look at some more characteristics in particular of the sine and the cosine graph. All right, sine and cosine, the domain of it, well, these graphs go on forever to the right and to the left. So we say that the domain of each one of these graphs is all real numbers, because these would just keep going and going. So here we would write it as parenthesis -infinity, comma positive infinity, parenthesis. And then same over here for cosine. Now the range is what's the highest point and what's the lowest point. This is our range. And so your plain graph without any numbers next to it, your high point and your low point are going to be 1 and -1. So that's our range. So it reaches 1 and -1. So I don't use parentheses, I use brackets. -1 to 1. And then the same thing is true for cosine. Okay, its lowest point is equal to -1 and its highest point is 1. Okay, symmetry. We did this way back before spring break. The symmetry for cosine, or excuse me, sine, is you can flip it upside down and it looks the same. When you can do that, we say that it is an odd function. It is symmetric with respect to the origin, 0, 0. Okay, the cosine graph was an even graph. That means you could fold it along the y-axis. So we say it's symmetric with respect to the y-axis. All right, the amplitude. Well, if there's no numbers on this graph, they're just plain sine and just plain cosine, the amplitude was 1. And it repeats, this cycle repeats every 2 pi units or 360 degrees. So we could say that the period is 360 degrees, or we could say it's 2 pi. And the same thing is true for cosine. They both have the same period. They're going to repeat over the same distance. Now, what we refer to as the critical points. The critical points are the axes on your unit circle. Critical points would be 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. All right, those are referred to as your critical points. And the reason we call them critical points is we use what the sine and the cosine is at these different places in order to graph it. All right, so what I mean by that is, let's take a look here at the sine. Okay, when I'm at 0 degrees, that's the first critical point. Okay, the sine in that case is equal to 0. Okay, so my first critical point, 0. When the angle's 0, the sine is 0. Okay, now when I go up to 90 degrees, pi over 2, my sine is equal to 1. So my next critical point is pi at 90 degrees, sine is 1. Okay, my next one is when the angle is 180 degrees, or pi. Now sine is 0 again. So at pi, sine is 0. And then as I keep going, and I get to 270 degrees, sine is negative 1. So that's at 3 pi over 2. Sine is at negative 1. And then when I'm back to 2 pi, it starts all over again. So here I write 2 pi 0. So the pattern that it's following is when you're graphing sine, sine starts at the origin, 0, 0. And it goes, I'll put it right over here. It goes 0, then it goes to its max, then it goes back to 0, then it goes to its lowest point, and then it goes back to 0. So it goes 0, max, 0, min, 0. Okay, now cosine is doing just the reverse of that. Okay, so if we take a look at the cosine, okay, here's our cosine curve. All right, it's got the same critical points, but at the beginning, it's at 1. So it's 0, 1. Then at 90 or pi over 2, it's 0. Then at 180, it's 0. And then at 3 pi over 2, it's back, at 180, it's negative 1. And then it goes at 270, at 3 pi over 2, it's 0 again. And then at 360, it's back to 1. So it goes max. If you look at the order now, max, 0, min, 0, max. And that's your 5 critical points for cosine. So here I just cleaned it up a little bit so that you can see the pattern. Okay, so your cosine goes max, 0, min, 0, max. Your sine goes 0, max, 0, min, 0. So that's the difference between the two graphs, and it's just describing how you graph them. Okay, this one starts at its max. Cosine then goes to 0, then goes to its lowest point, then goes back to 0, then goes to its highest point. And when you look at the graph of sine, it starts at 0, then it goes to its max, then it goes back to 0, then it goes to its min, then it goes back to 0. All right, the x-intercepts. The x-intercepts are going to be, so here's a sine and a cosine graph on Desmos that I provided you a link on. So right now I've got sine graphs. So if I want to look at what the x-intercepts are, I've got 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. You see a pattern. Every multiple of pi. Now if we clear that and we look at the x-intercepts of cosine, they cross at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi, 11 pi. So you can see the pattern there. It's odd multiples of pi over 2, 3, 5, 7, 9, 11. So that's your x-intercepts for both functions. Okay, so for pi it was just 0, or for sine, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc. For cosine it was pi over 2, then 3 pi over 2, goes by odd numbers, 5 pi over 2, 7 pi over 2, 9 pi over 2, etc. Odd multiples of pi over 2. All right, the y-intercept, there's only one for each. That's where it crosses the y-axis. So here's our y-axis. The sine crosses it at 0. And cosine crosses the y-axis at 1. So this is the point 0, 1. That's your starting point. And for sine, it's 0, 0. Okay, our maximums and our minimums. Where's the high points? Where's the low points? Well, they're going to be just the reverse of these x-intercepts. So if you look at, for sine, the high points, let's drag our sine graph back over. Okay, here are our high points. Our high points are at pi over 2, a low point at 3 pi over 2, high point 5 pi over 2, low point 7 pi over 2. Just like those used to be when I did cosine, those were the x-intercepts. There's our cosine graph. See our x-intercepts? So if I graph both of these at the same time, let's change the color on this so we can see the difference. We'll change the sine to green. All right. So the maximum here occurred where an x-intercept occurred here. The minimum occurred where the other x-intercept occurred. And it just alternates. This a max is where this x-intercept happened. So our maximums and our minimums, okay, our maximums, the highest point was 1, and the lowest point it ever got to is -1. And then the same's true for cosine. The highest point is 1, and the lowest point is -1. Okay, now on your first cycle of sine, your high point occurs at pi over 2, and your first low point occurs at 3 pi over 2. Okay, over here for your cosine, your first high point occurs at 0, all right, and your first low point occurs at pi. And then it just repeats. All right, now we're going to start graphing these, and to graph them, you have to be able to look at the equation and be able to tell it's the characteristics of the graph. So for example, when the number out in front, that stands for the amplitude. So whatever that number is, that's where your high and your low point is going to be. That's this value right here. The A is your amplitude. The B is the frequency. Okay, the frequency is how many cycles you see between 0 and 2 pi, from 0 to 2 pi. Okay, so right now in this problem, A is equal to 2 and B is 1. In the next one over here, A is equal to -2 and the B value, there's nothing there, so we assume that there's a 1 there. That's our frequency. So how you know what these look like is if you go to that Desmos graph that I linked you to. Okay, let's take a look at 2 sine theta. All right, so I'm going to get rid of the cosine. Now we're just looking at sine. Now what this little slider does, it allows you to change this A value. So I'm going to click that, and I'm going to change that to a 2. And as you see when I do that, all it does is it changes its amplitude. The period is still going to be 2 pi. When you're looking at this, you see one cycle, a hill and a valley between 0 and 2 pi. So it didn't affect the cycle at all or the period, it just affects the amplitude. Okay, now as that amplitude gets smaller than 1, it gets closer to the y-axis. It flattens out. When it goes negative, it flips over the y-axis. So that's an A value that's -1, and that's an A value that's -2. Again, the periods are still going to be 2 pi. In this case, it's just upside down. I see one cycle between 0 and 2 pi. Okay, now if we get rid of I'm going to unclick and click on the 2 cosines. Okay, so let's get rid of the sine there. There we go. So the red one is the cosine. So when I make this a 2, it's just changing the amplitude. If I make it a negative, it's flipping it over the x-axis. Again, it doesn't affect the period at all. I still see one cycle. Here's one cycle of cosine between 0 and 2 pi. All right, so to graph them, you just need to know what your series is, or your order, 0 max or max 0. All right, this is sine. Its amplitude is 2. So instead of it going up 1, its highest point is going to be 2. Okay, so this line up here is going to be y equals 2, and this line down here is going to be y equals -2. All right, so what's happening is it is getting vertically stretched by a factor of 2. There's no negatives, so there's no flips, and the frequency is 1, so the period is going to be 2 pi divided by 1, which is just 2 pi. Okay, so on my chart here, there's here are my critical points. Okay, sine starts at 0, 0. Then it goes to its max, which is now going to be at 2. Then it goes back to 0. Then it goes to its minimum, which is now negative 2. And then it goes back to 0. So there's my graph. If I had drawn regular sine on here, it would have only gone up to 1 and negative 1. It would have looked like that. Okay, so for cosine, negative 2 cosine x, my amplitude is still 2, except it's getting flipped. Frequency is 1. It's getting vertically stretched by a factor of 2. And it's getting flipped because of the negative. Okay, so this does have a flip. Okay, the period is 2 pi divided by 1, which is just 2 pi. All right, now your high point and your low point now are going to be, it's going to go 2 up and 2 down. Okay, now when you start cosine, cosine starts at its max. It starts up here, but it's being flipped. So it's going to start down here. Okay, the 0 doesn't move because it's on the line that you're flipping over. Okay, this used to be the min, but now since you're flipping it, it's the max. And then here's my graph. So it's just an upside down cosine because of the negative 2. All right. If we were graphing 1/2 sine, our amplitude is 1/2, frequency 1. Now it's not getting stretched vertically, it's getting vertically squeezed. It's getting squished down towards the x-axis. No flips, and the period is still 2 pi. So sine normally starts at 0. So now let's say that this is 1 up here instead of being 2, and this is negative 1. So now this is 1/2. So sine goes, remember, sine is 0, max, 0. Its new max now is 1/2 at pi over 2. Then it goes back down to 0 at pi. And then at 3 pi over 2, it goes down to its minimum, which is now negative 1/2. And then at 2 pi, it goes back to 0. And if you're unsure, you can go to the Desmos graph that I sent you, and you would type in 1/2 sine x. Okay, so there's my normal sine. Now to see what 1/2 sine would look like, I'm just going to take the a and slide it to 0.5. I'm going to click on the sine here, and 1/2 sine would look like that blue graph. Okay, the last one is cosine. So I'm going to unclick these. It's 5/3 cosine. So here's a normal cosine. Now what I'm going to do is I'm going to make a 5/3. Well, 5 over 3 is 1.6. So I'm going to click on this so I can see what it looks like. Here it is if a is 1. And now if I make a 1.6, that's what my cosine is going to look like. It's been vertically stretched, but the period hasn't changed, nor has the midline. I'm just stretching up the hills and pulling down the valleys. See you next time.